It began, not with a bang, but with a whisper. Headlines started to flash across news tickers' security blogs. Microsoft cloud breached. U.S. government agencies compromised. The words felt heavy, echoing in the digital hallways of corporations and government offices worldwide. For many, the news was a sudden jolt, a stark reminder that even the most fortified digital fortresses have vulnerabilities. The initial reports were sparse, filled with technical jargon that obscured a simple, unsettling truth. Someone had gained access to a place that was supposed to be secure. An intruder was walking silently through the corridors of power, reading mail that was never meant for their eyes. This was not a random act of digital vandalism. It was a targeted, sophisticated espionage campaign. Security analysts scrambled to understand the scope and scale of the compromise. It was quickly apparent that this was not a minor incident. High-level government officials and enterprise leaders were among the targets. The attackers were not just rummaging through digital filing cabinets. They were selectively accessing sensitive communications. The breach raised profound questions about the security of the cloud infrastructure that underpins modern work and governance. If a behemoth like Microsoft could be infiltrated in this manner, what did that mean for everyone else? The story was a chilling one, a quiet alarm that signaled a new level of threat in an already complex cybersecurity landscape. To grasp the gravity of this breach, one must first understand what the Microsoft Cloud represents. It is more than just a place to store files or send emails. It is a sprawling digital ecosystem, a virtual office building that houses the daily operations of countless organizations, governments, multinational corporations, hospitals, small businesses. All rely on services like Microsoft 365, email, calendars, documents, collaboration tools, all within this interconnected environment. This centralization offers incredible efficiency. But it also creates a single, high-value target. Think of the Microsoft Cloud as a massive shared skyscraper. Each organization rents a suite of offices on different floors. Microsoft provides the building's core infrastructure, electricity, plumbing, and a master security system at the front door. This security system verifies identity, checks ID, and grants access only to designated floors and offices. For millions of workers, their entire professional life, communications, plans, intellectual property, resides within these digital walls. The currency of access in this digital skyscraper is not a physical key, but a token. When you log in with your password, the system gives you a temporary digital token, like a certified visitor pass. You show it at checkpoints, access your email, open a document, join a meeting, and the system lets you in. These tokens are cryptographically signed, carrying an official, hard-to-forge stamp of approval from the building's security office. This is what allows single sign-on, the convenience of logging in once to access multiple services. Reliance on signed tokens is both a strength and a potential weakness. It is efficient because each door guard only needs to trust the official stamp on the token. However, this creates immense power in the hands of the entity that controls the stamp. The core of this entire incident revolves around a single, powerful cryptographic asset, a Microsoft signing key. This key is not a physical object but a long, complex string of data. It acts as a master stamp used to cryptographically sign authentication tokens. Outlook, SharePoint. Each service checks the signature and, if trusted, lets you in. It is the ultimate source of trust, the digital equivalent of a minting press that prints currency. The attackers managed to acquire this key. The exact method was under intense investigation, but the outcome was clear. With this master key, they could forge authentication tokens for virtually any user in any organization using Microsoft's cloud services. They didn't need to steal passwords. They didn't need to trick users with phishing emails. They could simply mint their own all-access passes. Imagine a country's passport office. One special cryptographic machine prints and validates all passports that every border will accept. Now imagine a sophisticated spy ring steals that machine. They can print perfect official passports for any agents under any names. Those agents travel freely. Guards accept the documents as legitimate. That's precisely what happened digitally by acquiring the Microsoft signing key. This ability rendered many traditional measures moot. Multi-factor authentication stops password thieves. But here, attackers weren't logging in normally. They presented a token that certified they were already authenticated. The system, trusting the signature, saw no reason to ask for a password or code. The master key let attackers become anyone, CEO, government minister, systems administrator, and be welcomed without suspicion. The attack was not a single event, but a methodical process. Crash dump error, signing key exposed, forge tokens, impersonate users, access email, exfiltrate data. First, acquisition of the signing key. Investigation suggested the key was inadvertently included in a crash dump. A crash dump is a snapshot of a system's memory created when a process fails, to help engineers diagnose the problem. In this case, a system containing the highly sensitive key crashed. Its memory, including the key, moved from secure production to a less secure debugging environment. There, the attackers eventually found and exfiltrated it. With the master key, reconnaissance and targeting began. Not wide and noisy, but surgical and precise. They forged tokens for a specific list of high-value targets. By focusing their efforts, they minimized the chances of early detection. They wanted to quietly gather intelligence. Their goal was espionage, not disruption. Using forged tokens, they authenticated to Outlook web access as targeted users, with full access to email and attachments. They searched inboxes and downloaded data. Systems logged the actions as if performed by legitimate users. No failed logins, no resets, activity looked normal. They likely added forwarding rules, planted malware, stole other credentials, and prepared backdoors, assuming breach and moving quickly before the key was revoked. The impact of the breach extended far beyond the initial victims. It sent a shockwave through the cybersecurity industry and across the global community of cloud customers. Security teams scrambled worldwide, racing to see if they had been targeted. Microsoft released indicators of compromise, technical clues like IP addresses and log artifacts that organizations use to hunt for intruders. Thousands of analyst hours and emergency consulting fees followed, sifting through mountains of data for subtle fingerprints. Government response was swift and stern. CISA issued directives. Congressional committees announced hearings demanding answers. The breach became a geopolitical event, highlighting state-sponsored cyber espionage tensions and exposing dependence on commercial cloud providers. It forced hard conversations about concentration of risk and accountability when a vendor failure leads to national security compromise. For affected organizations, damage was significant. Sensitive but unclassified government communications, diplomatic correspondence, and corporate strategic information. The full extent may never be publicly known, but potential strategic disadvantage is immense. Beyond data, trust eroded among citizens and customers. Microsoft devoted enormous resources, revoked the stolen key, rolled out enhancements, and made advanced logging more accessible. Meanwhile, victims faced forensic, legal, and reputational costs. This costly incident provides clear lessons. First, key management and rotation. Signing keys are the crown jewels. Store them in HSMs and rotate them rigorously. Second, shared responsibility with vendor transparency. Don't blindly trust. Ask how keys and logs are protected, and require comprehensive visibility. Third, embrace zero trust. Never trust. Always verify. Continuously monitor token behavior, and segment to limit blast radius and lateral movement. We become stronger by learning, building a more resilient foundation for everyone. Breaches like this show why cybersecurity is everyone's job. Subscribe so you don't miss the next episode. where I'll show how to detect token misuse in your own cloud system.